Well, hello class. Alright, so this is going to be our final lesson of Chapter 2, Lesson 210. And in this lesson, we are going to be talking about solving inequalities. So things like greater than, less than, greater than or equal to, less than or equal to. And this time, we're going to be focusing on inequalities that have either multiplication or division in them. And keeping in mind, again, that multiplication and division are opposites of each other. So just like with the equations, the way we get rid of multiplication is we divide, and the way we get rid of dividing is we multiply. The picture, I have absolutely no idea. My daughter's put this on my iPad. I'm pretty sure it's an evil ice cream cone eating a piece of watermelon. Could possibly be a cupcake eating a piece of watermelon. No idea. Thought it was interesting. Thought you would find it was interesting. So there we go. We're starting with a completely random and strange picture. All right. So let's go ahead. And again, this is going to be very similar to how we solve equations that involve multiplication and division. Okay. So let's move forward. So keep in mind the idea of opposites. And again, if we're multiplying, we're going to divide. And if we're dividing, we are going to multiply. And then also, whatever we do to the variable side, you always start on the variable side because you're trying to get the variable alone by itself. You also have to copy over on the other side, which is where the answer ends up coming from. All right, so let's take an example of an inequality like 4x is greater than 40. Okay, and I'll do the first one for you, and then you're going to do a couple on your own. All right, so, whoops, sorry about that. All right, and so let's go ahead and let's solve this one. And so 4x is greater than 40. What really is happening to the x is it's being multiplied by 4. So we're going to undo that by dividing by 4. Now, if I divide the left side by 4, and that's really where I start, I also have to come over here to the right side and divide it by 4. On the left, you have 4 times x divided by 4. The 4's will cancel out. Really, 4 divided by 4 is 1, and 1 times x is x. We're really using the multiplication identity property there. But that's okay. Basically, the 4's cancel out. You're left with x, and 40 divided by 4 is 10. Now, sure enough, if I check this, if I take any number that's bigger than 10 and put it into the original maroon equation, I will find that 4 times something bigger than 10 will in fact be bigger than 40. And again, if this is one of those questions where they want you to graph it, no big deal. You just put a little number line with a little tick mark in the middle. The middle number will be 10. It'll be an open circle because it is strictly greater than. And since it's greater than, we're going to shade to the right. Alright, and we're going to put our variable always on the right. So that's the graph of x is greater than 10. And that is the solution for this one. Alright, so moving forward, let's take a look at 2 more examples. Let's look at negative 21 is greater than 3m, and it doesn't matter which side the variable's on, just leave it where it is. And then another one, also with the variable on the right, 36 is greater than 9t. So go ahead and pause the video, and I want you to solve both of these inequalities, including the graph. And then as soon as you get those 2 done, go ahead and resume the video, and we'll make sure your answers match mine. Alright, so pause the video now. Okay, welcome back. So what you should have done on the first inequality, since you have 3 times n, we're going to start on that side. We're going to divide that side by 3 so that the 3's will cancel out. Well, if I do that on the right, I also have to do it on the left. And negative 21 divided by 3 is negative 7. And the greater than symbol just carries down. And 3 divided by 3 is 1, and 1 times m is just m. So we're going to get all of the m's that are less than. Now be careful. The m's are smaller than negative 7. Now, if you want to rewrite it at this point with the variable on the left, be careful. You're describing the m's that are smaller than negative 7. So if you decide to reverse it to have the variable on the left, you have to be a little more careful than you were with equality. And that is, you have to keep the big part and the small part in the same place. So what I mean by that is in the original inequality, the negative 7 is the big part, right, because the mouth is eating it, and the m is the little part because it's the part with the little side of the arrow. So if I reverse it and put the variable in the front and the negative 7 in the back, again, the little part has to be towards the m and the mouth has to be towards the negative 7. Alright? I didn't actually reverse the inequality. I mean, I did. I reversed the inequality sign, but it says the same thing. And what it basically says, if I graph it, is I'm going to start at negative 7. It's an open circle because of the strict inequality. And I want all the m's that are smaller than negative 7. Again, even though I'm shading to the left, I still put the variable over here on the right. And let's fill that in. Be very careful when you do your shading that it goes right to the circle, but it does not go inside the circle at all. Okay, the circle should be empty to show you that it is strict inequality. All right, and the last one, what you should have done on it is, go ahead, I'm going to reduce the size of this a little bit. All right, divide both sides by 9, so you start with this side, and then you also have to do it over here. Again, the 9's cancel, you get t. The greater than sign stays greater than, and the left side for 36 divided by 9 is 4. 4 is greater than t, or if I rewrite it, same discussion as before, t is less than 4. Both of these inequalities right here say the same thing. It describes the set of t's that are smaller than 4. So that's an open circle on 4, and it's all the things over here that are smaller to the left of 4. And again, the variable is t. All right, so that's what you should have got when you solved this. All right, now that brings us to the very big difference. There is one very big difference. Think Clifford and the big red dog. That's why the big red letters. Okay? One very big difference when you're solving an inequality than when you're solving an equation. And it has to do with what happens when there are negatives. So take that same problem we just finished. 36 is greater than 9t. Suppose it's 36 is greater than negative 9t. All right, I want you to notice that this time there's a negative number with the variable. Now, to get rid of that negative number, we're multiplying t times negative 9. We have to divide by a negative 9. The 9 divided by 9 will get rid of the number part, and negative divided by negative is positive. And so that'll leave me with just plain old t down here. So if I did it on the left side, I also have to do it on the, on the right side, I also have to do it on the left side. So 36 divided by negative 9 is a negative 4. Now, here's where there's a big difference, all right? When you divide or multiply by a negative number, like the thing that we wrote in, like in this case we wrote it in the black ink, okay, the thing that we did to both sides of the equation, when we multiply or divide by a negative number, think about what happens when you go into negative land. Remember when we talked about order? 1 is less than 2 is less than 3 is less than 4. In positive numbers, the bigger the value, the bigger the number. But if we switch over to negative numbers, it's the exact opposite, right? Negative 1 is bigger than negative 2. And negative 2 is bigger than negative 3. Just think about it. Would you rather owe somebody $1, $2, or $3? So in negative land, bigger values are worse. They're actually smaller. Well, so whenever we switch from positive land to negative land, or from negative land to positive land, basically the order all switches direction. So whenever I multiply or divide by a negative, I do that. I take positive things and put them into negative land, and I take negative things and put them into positive land. And because of that reversal, what I have to do when I do this is I have to reverse the inequality. So the greater than sign above becomes a less than sign. All right, so for right now, that's just going to be the rule. We will talk about this a little bit more in class and clarify it. But for right now, the rule is if you multiply or divide by a negative number, then you have to reverse the inequality. All right, now let's finish this one up. The number line for this one would start at negative 4. Okay, t it's all the t's that are bigger than negative 4. By the way, you could reverse this if you want. So this is t is greater than negative 4. That's not the same thing as what we did here. Here we literally reverse the inequality. When I go from here to here, the t is still towards the mouth, and the negative 4 is still towards the little point. Okay, I'm just writing the variable first. And this is an open circle because of the strictly greater than. And all the greater than numbers are up here to the right, so we'll shade that direction. And we'll put our little variable t underneath here. And so there is the graph and the solution. T is greater than negative 4. All right, so just like before, let's go ahead and let's do one more example together, and then you can do a couple on your own. So m divided by 4 is greater than or equal to 2. Now, again, the way I want you to show your work is the same with equations. Okay, I want you to put parentheses around both sides because m divided by 4 has to be undone by multiplying times 4. And if I multiply the left by 4, I'd sure better multiply the right by 4 too. So the 4's dividing something, m in this case, by 4 and then multiplying by 4 just leaves you with m. And on the right side, 2 times 4 is 8. Now, did I multiply by a negative number? No, I multiplied by positive 4. So the inequality stays in the same direction. So I get m is greater than or equal to 8. Okay, the graph for that will be, we'll start at 8. We'll draw a circle. This time the circle is going to be filled in because it's greater than or equal to 8, and it's greater than, so we'll shade to the right. And as always, the variable goes over here on the right. Okay? All right, so the next two problems, I want you to pause the video and do it on your own. So the first one's going to be t divided by -3 is less than 7, and the last one is 5 is less than r divided by 7. And I want you to be particularly careful with this second inequality. With this second inequality. And the reason I want you to be really careful is if you look at it closely, it is t divided by -3. So to get rid of that, I'm going to move this down here so it's got a little bit more room. You're going to actually have to deal with that negative thing. You're going to multiply both sides by -3. And when you do that, don't forget about what happens to the inequality right here. Okay? All right, so pause the video. Take your best stab at solving and then graphing both of these inequalities. And then as soon as you're done, resume the video and we'll make sure that we get the same answers. All right? Be back in just a second. All right. So you should have taken the first one, written down the original inequality, then drawn two sets of parentheses on either side, and what we're going to do is we're going to multiply by a -3. Okay? Okay, if I multiply the left side by -3, I've got to multiply the right side by -3. Okay, and over here on the left, the -3's cancel out, and I get just t. On the right, 7 times -3 is a -21. Now, the inequality, because I multiplied by -3, this is the one you have to reverse the inequality. So instead of t less than -21, it's actually the t's that are bigger than -21. The graph is going to just look like every other graph. We're going to start at -21. It'll be an open circle, and we want things that are bigger than -21, so we'll shade to the right, and the variable goes over here. Now, the last one is also going to be a little bit tricky because, again, I have kind of run out of space here. So let me go ahead, and it's not going to be perfect, but let me move as much. Oh, I did get it all. Good. Let's move that down here so we have a little bit more room. And let's solve this one in red. All right, so start on the variable side. R is not supposed to be divided by 7, so we're going to multiply by 7. If we do that to the right side, we've also got to do it to the left side. The 7's cancel. You get R. 7 times 5 is 35. And we multiplied by a +7, so the inequality stays the way it was. So it's 35 is less than r, which does mean the same thing as r is bigger than 35. It is easier to always have the variable on the right because then when I graph it, start at 35, it is an open circle on 35. Now the arrow will actually point in the same direction as the inequality arrow. Okay, so this points to the right, so does the arrow. That only works, though, when the variable is on the left. So that is the motivation to right here. This basically says the same thing. Either way, it says 35 is smaller than r. R is the bigger thing, 35 is the smaller thing. And both of those lead to this graph. All right, so, okay, I know that's a lot, but that's it. And so, whoops, let's erase that. Let's go ahead and wrap this up. So this is my little dog Woofy, and actually he does have a TLS connection. It was actually Miss Hutton's daughter who found him living out, not being very well taken care of, and we adopted him. And his name used to be Wolfie. It's Woofy now. So Woofy, I got a real quick question. Do you have any final words for our pre-algebra students here at the Lexington School? What's that? All right. Woofy says ARF. And with that, we're going to sign off. Good night, everybody.